Hi, the topic today is about the intermolecular forces. So, intermolecular forces is a force between two molecules or maybe between among many molecules. So, it kind of makes the molecules to be present together in a group in a kind of liquid phase, solid phase, thing like that. So, uh, this is called the intermolecular force. And the intermolecular forces actually, there are many different kinds of these intermolecular forces. But anyway, because it is a force, right? So it is uh, a type of fundamental forces. Right? So in your general physics, you may know that the force in the nature can be divided into four fundamental forces. And the four fundamental forces are listed here. First, the strong nuclear force, and secondly, the weak nuclear force. Strong nuclear force and the weak nuclear force present in a nucleus. As you may know, that in the nucleus you have many protons inside, sorry, and the protons themselves contain positive charge. So you have electrostatic repulsion or the repulsive force among protons in a nucleus. That means you have to have something that is stronger than the electrostatic repulsion here, and these are the nuclear forces, strong and weak nuclear force. So this can hold the nucleus to be like that, right? To dominate the electrostatic repulsion among the protons inside. Next is called the electromagnetic force. As you know, the electricity and the magnetism are present together sometimes. Um, if you heard about the right-hand rules in the physics, right? When you have a magnetic field circulates on around an axis, right? You're creating a kind of electricity out of that, right? So this is a kind of when you have force turn the turbine in a circular motion, you can then creating the electricity out of that kind of thing, right? So this is called the electromagnetic force. Is a force by this kind of electricity and the magnetisms. And lastly, the gravitational force. This is a kind of weak force, right? Because you can feel the gravity when you have a very, very massive object, like the gravity among planets and the sun, or the gravity between the earth and the moon, and also the gravity that hold ourselves together on the earth, right? Because everything is dragged down to the surface of the earth by the gravitational force, right? But you cannot feel the gravitational force between people because our mass is very low. That means the gravitational force is very, very kind of very weak force, right? As you may know, the gravitational force F here is equal to gmm divided by the r square, right? And the g value is minus something, right? With the power of minus something. I cannot remember anyway. But yeah, as you know, the gravitational force is very weak, and strong and weak nuclear force are in the nucleus, right? So the intermolecular forces that you may familiar with when you have learned in your high school or in the Gen Chem, they are all kind of electromagnetic force. So the intermolecular forces can be divided into many types. Um, like I have listed here, right? So intermolecular forces can be divided into several types. Listed here in the green color is are the intermolecular forces. You familiar when you've learned your Gen Chem or in your high school? The very first type is the London dispersion force, right? And we call that dispersion. The word dispersion here because this kind of force is a kind of electrostatic force that happened because of the movement of electrons in a molecules, right? So when the electron moves in the molecules, sometimes it's densely packed on one side than the other. So this creating the electrostatic charge on the surface of the molecules and creating this kind of electrostatic attractive force, right? So this is the London dispersion force. And because you know about the polarity, right? If you have a dipole molecules, positive charge one side, negative charge on another side. So the dipole molecules can come up together, interact together. So we call this as dipole-dipole interaction. And next, we have dipole-induced dipole interaction as well, because sometimes you have a neutral molecules, but the neutral molecule over here can be like induced to be dipole molecule as well by the electrostatic charge of the solvent system, for example. I will give you the example of these kind of forces afterward. Then, ion dipole interaction. So this kind of thing is like when you dissolve, let's say, sodium chloride into water, and sodium chloride dissociated into sodium ion and chloride ion. So positive sodium ion can interact with the dipole moment of the water molecule, and also the negative charge chloride ion can also interact with the positive charge, the positive pole of the water molecule as well. Right. So this is called ion and dipole interaction because it's the interaction between ion and the dipole molecule. Right. And next, the hydrogen bonding. This is very famous in your high school or your Gen Chem. But what I want to show you here is the wording we use. We use the word bond, hydrogen bond, right? Because the strength of this interaction is so strong comparatively with the covalent bonding. And because of this hydrogen bonding, sometimes we're creating the covalent bond out of this hydrogen bond. But how we can change the hydrogen bond into permanent covalent bond, we'll talk about it later. But actually, it's the thing that we use to explain the dissociation of acid and base in the water. We use this kind of intermolecular interaction, the hydrogen bond, mainly. And these 5 intermolecular forces, you may heard about these in your high school or in your Gen Chem. But now, we also have something else as well, but relatively weaker than the previous 5 forces, right? The halogen bond. So it's quite similar to the hydrogen bond, but instead of using hydrogen to creating the intermolecular interaction, in this case, the intermolecular interaction is centralized on the halogen atom in a molecule. So it's a kind of electrostatic thing as well. And the last one is called pi interaction. The pi interaction here is like you have to know the pi bond, right? From the hybridization theory, right? We have pi bond. We also have the pi conjugator system. If you have pi bonding that is linked together in series, so we call this as pi conjugator system. Normally, the pi interaction creating around this pi bond, so we call this as the pi interaction. And we also have subtypes of the pi interaction, like pi-pi stacking in graphite, right? If you know the graphite, a kind of plate of carbon, right? So linked the benzene ring together into a very giant plate. This is called graphene. And if you have graphene stacked on top of each other, we have pi-pi interaction. Similarly with the DNA strand. The ACGT bases pair is like stacked up on top of each other by this pi-pi interaction as well. And we also have pi with cation pi with something else that we're going to talk about this afterward. So this is kind of outlined or listed of the list of the intermolecular forces. So next we will go deeper in details in each particular intermolecular forces in the next video.